Hey everybody, in this video I'm going to go over question 23.25 in Brown-Lemay-Burston 13th edition, and this has to do with determining the coordination number and oxidation number for the metal in each of the following complexes. So there's a lot to this in terms of terminology. So the first thing is we want to know what it means by complex. So the complex is the thing that's in the square brackets. So even though we know that Na, sodium is a metal, Na2, let's see, CdCl4, what we're really talking about is what this oxidation number is. We know that the oxidation state, or the charge in this case, of sodium is always going to be 1 plus. That's something that we know about the alkali metals, is they always have that charge. So it's not a question to determine what that is. We know that also, again, because it's asked for the thing in the complexes. And the complexes are always signified by the square brackets. So for this problem and all of these problems, I think it's important to be able to split them into their parts. So if we notice, we have this, and then we have the complex ion. And so we need to take this and we need to be able to say, well, this is the positive side of this thing and this is the negative side of this thing. Whenever you have a compound like this, we always need to find the positive and the negative side of this. And remember that in an ionic compound, or in a compound like this, it is ionic, and then with a complex ion and a regular cation, the charges will add up to 0. So this thing, each of these sodiums have a 1 plus, so that makes this side a 2 plus. So that means this whole thing here, this whole thing has to add up to 2 minus. So how do we get that to do that? Well, we know that chlorine is always a minus charge. So if chlorine is always a minus charge, that makes the contribution because of chlorine 4 minus. So if this is 4 minus and we need to get to 2 minus, that means that cadmium is going to be a 2 plus. So the oxidation number of cadmium in this compound is 2 plus, and its coordination number, that is how many ligands are around, or how many donor atoms are around the cadmium. In this case, there's 4. Okay, the cadmium has 4 things around this. So if I were to draw what that looks like, you have a cadmium ion, and then you have a chlorine, a chlorine, a chlorine, and a chlorine. Okay, so that's part A. So now part B, again, it's going to be kind of the same thing over and over again. So we're going to have K2 and then MOOCl4 like that. Okay, so now we're going to figure out the charge. Okay, again, split this up. We know that this is the positive side of the atom, this thing, or the molecule in red. This is the positive side of this. And we know that potassium always has a 1 plus charge, so that means that this side is a 2 plus. So in order to get this over here, that means this whole thing has to be a 2 minus. Okay, so now we need to go through and use our knowledge of ions to know what is going on here. So each chlorine is a 1 minus, so there's 4 of those, so this is a 4 minus. Oxygen, the oxo ligand, is a 2 minus, so that's 2 minus, so that equals 6 minus from the ions. We have to get to 2 minus, so that makes molybdenum 4 plus. Okay, and so the molybdenum ion is a 4 plus oxidate, or the molybdenum in this case has an oxidation number of 4 plus. And again, its coordination number, how many donor ions are attached to the metal, well, we have the oxygen and then we have the 4-chlorine. So when we draw this, we would have molybdenum in the middle, then we would have an oxygen, and we have a chlorine, 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 chlorine. Okay? Okay, so let's do the next one. Okay, so now we have a complex ion where the cation is the complex ion. Okay, but again, we should be able to split this into the two sides. This side is the negative side, because that's whenever we have a compound, the negative half is always listed second. This side is the positive side. So on this side, we have a 1 minus, because there's only one chlorine. And so so that's all by itself. That's a 1 minus. So that means that this side is a 1 plus. Okay, so somehow the whole thing has to add up to 1 plus. This whole complex ion has to add up to 1 plus. So we have, this guy is a, each chlorine is a 1 minus, so that makes this 2 minus. This is ammonia, and remember it's called amine in complex ions. So these are neutral, so that's going to be 0. So now we need something from cobalt that makes all of this add up to 1 plus. So that makes this a 3 plus oxidation number. Okay. And again, when we look at the for the coordination number, again, a coordination number is how many donor atoms are around it. And so you would have cobalt in the middle, you would have 2 chlorines, and then you would have 4 ammonias sticking off of that. So that means that its coordination number is 6. Okay, so now let's look at part D for this thing. Okay, so part D now just gives us an ion. Okay, it doesn't give us the counter ion to this plus, or to this negative ion. So it's only the complex ion. Okay, so cyanide, or when we use it in coordination chemistry, this CN is still a minus. It's called cyano when it's in a coordination compound. So again, there's 5 of them, so this is 5 minus. So how do you get 5 minus to get to 3 minus? Well, this must be 2 plus. 2 plus and 5 minus gives us 3 minus. So the oxidation number of nickel in this case is 2 plus. And then the coordination number, again, is how many donor atoms are around this. And so it's going to be 1, 2, 3, 4, 5. 5 donor atoms around this, so its coordination number is 5. Okay. So now in part E here, okay, is we have potassium, K3, and then the complex ion here is with vanadium and the oxalate ion. Okay, so again, we should be able to split this. Okay, and so now everything on this is 3 plus, because there's each of these potassiums is 1 plus, so that makes the total 3 plus, and so that means that this side is going to have to total 3 minus. Okay, so each oxalate, or what we call in coordination compounds oxalato, each oxalate has a charge of 2 minus, so that makes this 6 minus because there's 3 of them. So how can 6 minus equal 3 minus? Because this is going to be a 3 plus. Okay, so the coordination, the oxidation number is a 3 plus in vanadium in this compound. Now, in terms of the coordination number, this is the first one in this problem where we have this, but oxalato, or the oxalate ion, this thing looks like this. Okay, so this is where the negative charge is. There's a carbon, and then there's a negative charge. So this thing is what we call bidentate. It latches onto the atom, like the vanadium, in two places. So each one of these has two donor atoms attached to it. So if there's two donor atoms for each oxalato, and there's 3 oxalatos, that means that the coordination number for vanadium is going to be 6. So we would have something like this, where even though it's the same, it's a compound, we have only three ligands. They're bidentate, so now we have 1, 2, 3, 4, 5, 6 as our coordination number. Okay, so now let's do part F now. Part F. So we will do Zn, and then that parenthesis En stands for ethylene diamine. Okay, and then with a Br2. So again, we should always be able to split this. Okay, and bromine is 2 minus. Remember, each bromine is 1 minus. There's 2 of them. So this side of the molecule here, this side of the molecule is 2 minus. So that means this side of the molecule must be 2 plus. And so ethylene diamine, let's keep that in mind, that ethylene diamine is a compound. So it's a ligand. And so this has a neutral charge. So how can 0 equal 2 plus? That means that zinc here has to be a 2 plus charge. And then again, ethylene diamine is what we call bidentate. Okay, it bites. Dent is the root for teeth, and so like a dentist. So bi meaning 2. So this bites in 2 places. So ethylene diamine is bidentate, so we have a zinc, and then around the zinc we would have the ethylene diamine here, and then the ethylene diamine here. So it would be bonded, even though there's only 2 compounds bonded to, or 2 ligands on it, it still counts as having a coordination number of 4 because it's bonded in 4 places. Okay, so that goes over coordination number and oxidation number for complex ions. Hope this helps. Have a great day.